All right, let's check our circumference problems first. So that way you've got those correct, and then we're going to do one more thing today with circles. So the first one, I had you have a diameter of 4. So all you had to do was do 4 times pi. Put that in your calculator. You should have got 12.57 rounded to the nearest 10. Okay, or hundredth, sorry. Number 2, I had you a diameter of 12. So you do 12 times pi, and you should have got 37.70 rounded to the nearest 10. I think it was 6999 or something. So when you round to the nearest hundredth, it made that one go up, which was 37.70. Then you had diameter of 7.5. So you just do 7.5 times pi, and you should have got 23.56. Okay, so that's the ones where I gave you the diameter. Then you had to do the ones with the radius, okay, given to you. So number 4 was a radius of 5, so you had to double that, okay, to get diameter and multiply times pi. So 10 times pi should have gave you 31.42. This number 5 was a radius of 30, so you had to double that and do times pi, and you should have got 188.50, rounded to the nearest hundredth. And then the last one was a radius of 5.7, which should have been 11.4. Okay, doubled times pi, and you get 35.81. All right, so that's doing circumference. And what you're finding with circumference is the distance around the circle. So that, like a string going around, like the perimeter, except there's no sides, so it's finding that. Today, we're going to use another formula, also a very simple one. It is a little tricky. It's got a little trick to it, but basically, it's going to find, instead of finding the distance around, just like you found a perimeter of a rectangle, we're going to find the area, or all this space in here, like if you were going to cover it or paint it. We're not talking about volume. We're not talking about filling it up with like a gas, solid, liquid, because this is not a three-dimensional shape. You can't pour anything into this circle. It would fall right off the board. So we're just talking about the surface area. That formula is pi radius squared. So just like the circumference one, you had to get the diameter. In area, you got to work with the radius. Okay, so that's the first little trick to it. The other thing, if you notice, if you go back to if you were in algebra or even pre-algebra, we did this. We're not squaring the pi times the radius. We're only squaring the radius. So that matters. You know, if you think about that, let's just for argument's sake use 3 for pi instead of 3.14. If I was to do, let's say the radius is 2. If I was to do 3 times 2 first and get 6 and then square it, you end up with a pretty big number with 36. But if I do it in the right order, meaning I only square the radius, that's the only thing that, it's not in parentheses, so you're not squaring both of them, you're only squaring the radius. That means if the radius is 2, you square it first, you get 4, and then you multiply it times pi, which was about 3, you get 12, which is much different than 36. So you've actually got to square your radius first, then multiply times pi. So what I do in the calculator is I work backwards. Instead of doing pi times radius squared, your calculator is probably going to do the multiplication first and then square it all. Work backwards. Square your radius first, then multiply it times pi when you're done. Okay, so let's do a couple examples of that. Okay, so let's say I have a circle with a radius of 3. Okay, so the radius is 3. So what I'm going to do in my calculator is I'm going to square 3, or just manually hit 3 times 3 and then multiply that times pi. Okay, so let's do that. I'll get my calculator out here. Once again, to get pi, you need to turn it sideways. So in this case, I can do this in my head, but if it's 9 times pi, the area is 28.27, rounded to the nearest hundredth. So try that and see if you're coming out with the same thing. Let's do another one. Let's say the radius is 7.2. Let's make it a little bit harder. Well, maybe I can't do that in my head. Well, all you're going to do is square the radius. So you can either do 7.2 times 7.2, which is 51.84, or you can do 7.2 and find your square button, and it's 51.84. So leave that in there, because I did 7.2 times 7.2 times pi. And you should get 162.86, okay? So do it in that order. 7.2 times 7.2 times pi, okay? Now, just like yesterday, where we were working with diameter and I gave you some with radius, well, what happens when they give you a circle in these problems with a diameter, and you've got to use that formula? Well, the first thing you have to do is find out what your radius is going to be. You're not going to take 10 times pi, because that's diameter, and that's not what the formula calls for. You first have to half this and say my radius is 5, so it's 5 times 5 times pi. Okay, so 5 times 5 times pi is 78.54. So if you have a diameter of 10, first find your radius, square it, and then times pi. Let's do one more little trick as far as, same thing, but let's make it a little bit harder. So let's say we have a diameter of 8.4. Well, that means my radius is 4.2. Cut that in half, and then multiply it times 4.2 times pi. You're going to square the radius and then times pi. So 4.2 times 4.2 times pi. And that is 55.42. Okay, let me check that one again. 4.2 times pi. 55.42. Okay, so that's doing area, and obviously, like I said, that is different. That's finding the surface area. That's not finding the distance around. Okay, so that's what you're doing for this assignment. Okay, is finding the area. So find the area of these. Round to the nearest hundredth again. Okay, so this one's going to have a radius of 5. This one's going to have a radius of 3.7. Number 3 is going to have a diameter, so make sure you do some work first, of 16. And number 4 is going to have a diameter of 15. Okay, so do those 4 problems, check and see if you're doing them right, and we'll go from there.